Hi everyone. For today's class, we're going to look at the intersection between a quadratic curve and a straight line. Now, very similar to what we have done before when we are looking for the roots of a quadratic curve, whether they are two distinct roots, two repeated roots, or no roots at all, we can apply the same idea, right, to a quadratic curve and a straight line. Now, over here I have three examples where you will see that in example 1 or case 1, where you have a quadratic curve and a line where they intersect at two distinct points. Second case, only one intersection, and the third case, there are no intersection. Now, very similar to the previous topic, we will realize that the discriminant, right, of all the different cases will be slightly different. For case 1, the discriminant we will know is that it's going to be more than 0. All right. For the second case, it will be equals to 0. Equals to 0. And for the third case, it will be less than 0. Now, so when will the discriminant comes in? We have to first actually intersect both the graph together. So I'm going to try example 1 to show you. So your quadratic curve is actually y equals x squared, and your line is y equals x plus 2. So we're going to do simultaneous equation with both the equation. Therefore, we can conclude that x squared is equals to x plus 2. X squared minus x minus 2 equals to 0. So we still have to end it up in the form of ax squared plus bx plus c equals to 0 before we can check on the discriminant. All right, let's check on the discriminant. B squared minus 4ac in this case is actually negative 1 whole square minus 4, a is 1 and c is negative 2. And we worked out to be 1 plus 8, which is 9. And since 9 is more than 0, therefore we can conclude that there are two distinct intersections. All right, so that's how we understand it. Now we're going to repeat the same thing for case number 2. We're going to check the discriminant and see where we will actually end up having the answer. And likely it's going to be equals to 0. Let's check it out. All right, so x squared equals to 2x minus 1. So x squared minus 2x plus 1 equals to 0. And we check the discriminant, which is minus 2 squared minus 4 ac, and it is in fact 0. So our conclusion is that since the discriminant is equal to 0, therefore there is only one intersection, or one point of intersection. All right. Now, in the last case, we will look at no intersection situation. So we do expect our discriminant to be less than 0. So let's do a quick check. So x squared equals to negative 2x minus 5. X squared equals, or x squared plus 2x plus 5 equals to 0. And then we check out discriminant. B squared minus 4ac equals to 2 squared minus 4, 1, and 5. And that will be 20 minus 4. 20 minus 4 is negative 16, which is less than 0. So therefore, our conclusion is that there are no intersection. There are no intersection. Okay? All right, so no intersection between the curve and the line. All right, so I hope this is a good tutorial on how to identify if a quadratic curve and a line has one or no intersection. So we will use back the discriminant concept, and we're going to have to equate the quadratic and the line together first, move everything over to one side, leave it in the form of ax squared plus bx plus c equals to 0 before we check the discriminant to tell us. All right. Now, if you have any comment, please let me know. Put it down in the comment, and I will see you in the next video. Cheers.